sensorium. Radiation sensors, I've mentioned those from REM Oxford in the UK, and various optical sensors for light. These actually are great. We use these in our analytical system. It's a little ASIC that converts light intensity directly into frequency, so you don't need a separate A to D converter. The frequency output you can feed straight into a microcontroller, and it just counts the pulses. And they're linear over like 6 orders of magnitude, so very nice sensors. Okay, so a little bit on the two payloads to wrap up here. Cessflow, again, is the biology payload. We had Bacillus subtilis, and we had a halophile that likes to live in salt flats. This one grows in 3 days. That was fine. This one wants to grow in 3 weeks. That was not so fine. We could really never get them to grow very successfully in the lab or in space. But they forced us to fly a few wells of it just to see if we might get it to grow. We measure red, blue, and green transmittance. This is just what Pharmasat did, and I'll show you some optical curves. Excuse me in a minute. So the sensors I already talked about. This is the cross-section of one of the fluidic wells. The Bacillus subtilis go in dry form. You have to keep the wells fairly small in diameter so that when you add the fluid, it will displace all the air without leaving bubbles trapped behind. It does that pretty well. So the air comes out through something that's essentially Gore-Tex on the top here. And we have 12 of these wells per biounit, so 12 run at each time point. The next sort of level of engineering is the thermal system. And that's a plate of aluminum with Kapton tape on it. You might know this as flex circuit. It's inside all sorts of things, including local phones.